Let's see this identity property. What is this identity property? Identity element. Can anyone tell me in number theory, what is the identity element for addition? Identity element is like this. Let me tell you identity element. What is identity element? Identity element does not affect the operation. Identity element does not affect the operation. Does not affect the operation. Does not affect the operation. What it means? For example, can anyone tell me what is the identity element for addition? Which element does not affect the addition operation? See, you can notice this 0 does not affect addition. This 0 does not affect addition. What about multiplication? Which element does not affect multiplication? This 1 does not affect multiplication. So I can say that this is the definition of identity element. Identity element does not affect the operation. So identity element, okay, identity element basically is like this. If you have some operation, let's assume this is your set and this is your operation, then identity element is, remember, identity element is fixed for all. Identity element is something like this. What is identity element? Identity element E. It is something like this, that it will not affect the operation. So A hash E, that will be same as A. And E hash A, this will be same as E hash A, this will be same as A. This is the definition of identity element. So identity element does not affect the operation. Now remember one thing, very important note. Okay, so identity element is fixed for all elements. Okay, so it's like this. If you have this set, let's assume this is your set, so and this is your operation, then what is identity element? What is identity element? Identity element E, this is fixed for all. It's like this. Identity element is for all. Okay, so remember this identity element is this is fixed. This is fixed for all X, for all elements. This is fixed for all elements A. And what it means, if you take all the elements, okay, if you take any element from this set, if for all A, what will happen? Any element you take for all A, you can take E also, because E also belongs to this set. E also belongs to this set. Now I can say for all elements, what will happen? E hash A should be equal to A, and A hash E should be equal to A. Both of them must happen. Both of them should happen. Then we can say that this is identity element. So identity element does not change according to the element. Identity element is fixed for all. Let's see example. So tell me, in the set of natural number comma addition, do we have identity element? Is there any identity element? Can anyone give me a fixed element? Can anyone give me a fixed element? So there is no identity element here. There is no identity element here, because remember set of natural number. This is the set of natural number. So for this set of natural number, you can clearly see there is no identity element. Why? Because identity element basically means that this is E plus anything you take. Remember, this is fixed. And here you can take anything from N. Here you can take any element from N, anything belonging to N. Then what should happen? This should be same as A. Is there any element for which this will happen? Do we have any element? No, because you can notice 1 is not identity. You can clearly see 1 is not identity. 1 is not identity. Why? Because you can notice 1 plus 2, this is not same as 2. So 1 is not identity. 2 is not identity. Why? Because 2 is not identity, because 2 plus 3 is not same as 3. So there is no identity element here. We don't have any identity element. What can you say about set of whole numbers? Addition. Here there is identity element. You can notice this is fixed for all. This is fixed for all. Now you can notice that this 0 is fixed for all. With this 0, you can take any number from this set of whole numbers. You can take any number. The result will be 5. You can take any number, the result will be this. You can take any number, the result will be this. And also remember, if you take like this, then also result will be 5. 6 plus 0 is also 6. 100 plus 0 is also 100. So this 0 is the identity element. What about this? Is there any identity element here? You know, this is closed. Is it associative? Is this associative? This is not associative, because you can notice set of integers comma subtraction. Why this is not associative? This is clearly not associative, because you can very easily see that, for example, 5 4 3, you take these things, 5 4 3. Now you can notice that this and this, they are not same. What this will become? This will become -2, and -2 is not same as 5 minus 1, that is 4. So this is not associative, this subtraction operation. And what about this one? Is there any identity element? Any identity element do we have? Can I say 0 is the identity element? Let's check 0. Let us check 0. Can I say this is the identity element? This is not the identity element. Remember, see, if you take a minus 0, that will be a very good, very good, very good. But 0 minus a is not equal to a. Don't forget about this one. This is fine, but what about this? What about this? 0 minus a is not equal to a. Remember the definition of identity element. Identity element basically, identity element is something like this. These two things should happen. If you have identity element E, then what should happen? A hash E should be equal to A, and E hash A should be equal to A. So I can say there is no identity element here. Do we have identity element? No. So this answer is no. 0 is not the identity element. What about set of rational number comma multiplication? What about that? Set of rational number comma multiplication. Is it closed? Can I say this is closed? Yes, this is closed, because rational number multiplied by rational number, that is rational number. So this is closed. Is it associative? This is associative, because I told you multiplication is associative. Multiplication is always associative. So this is associative. Do we have identity element? Is there any identity element? Is there any identity element? Yes, there is identity element. Identity element E is equal to 1. Because if you take any element, then E multiplied by 1 will be A, and 1 multiplied by A will be A. So E is equal to 1 is the identity element. Yes. So E equal to 1 is the identity element. Okay, let's see this question. Something interesting. Set of natural number, comma, new operation I am defining. And this new operation is like this. A hash B, this is equal to maximum of A comma B. Okay, just look at this. This is new operation. A has B, this is same as, this is equal to maximum of A comma B. Tell me, is it closed? First you understand this operation. Anyway, okay, so let's start by understanding the operation. So first you understand the operation. So can anyone tell me what is -2 hash 2, what that will be? First you understand the operation. What is -2 hash 2? Invalid. This is the base set. Please consider the base set. This is invalid. Don't, because remember, your base set is set of natural number. So this is nonsense. Okay, remember, everything should come from the base set. Your base set is set of natural number. Don't forget about it. That is the reason I have taken this. Don't forget about base set. Your base set is set of natural number. Okay, now, so now tell me, what is 2 hash 2? What that is? That is maximum of 2 comma 2, and that is 2. What is 2 hash 1? That is also maximum of 2 comma 1, that is 1, that is 2. 1 hash 2, that is also 2. So this is the operation. Okay, now this is closed. Can I say this is closed? set of natural number comma hash, this new operation we have defined a hash b, this is equal to max a comma b. Is this closed? Yes, this is closed, because the result will be natural number. If you have two natural number a comma b are natural number, if these are natural number, then their max also will be natural number, then their maximum, because a comma b are natural number, their maximum will be either a or b. The maximum will be either a or b, so the maximum will also be the natural number. So this is closed. Is it associative? Is this associative? Yes, this is associative. What will happen? The maximum will be selected. Actually, the maximum of all three will be selected. For example, if I give you these three elements 2 3 2, if I give you these three elements, then tell me, these three elements I give you, then what will happen? Is this same as this? What is this? 2 has 3, that is 3. 3 has 2, what is that? 3 has 2, that will be 3. So this is the final 3. And here 3 has 2, that is 3. 2 has 3, that also will be 3. So 3 is equal to 3. So this actually will be associative. Okay, so this, yes, this is associative. What about identity element? Is there identity element? Do we have identity element here? Set of natural number comma has, and the operation, remember the operation, a has b, you already know a has b, this is equal to max of a comma b. Do we have identity element? What is identity element? E. Can I say e equal to 1 is identity element? Can I say 1 is the identity element? Can I say? Just check it. Can I say 1 hash a? Can I say this is equal to a? Right? Yes, correct. A hash 1, this is also equal to a. So yes, this is the identity element. So e equal to 1 is the identity element. So I can say, yes, there is identity element. Yes, there is identity element. E equal to 1 will work. What about set of integers comma this same operation, but with the integers? Okay, the operation is same, but now with the integers. Now what is the identity element? Now what is the identity element? Is there any identity element? Can I say, see, okay, wait, let me give you the identity element. Let me give you. So for 3, let me give you the identity element. For 3, the identity element I can give you as 2. For 2, I can give you identity element as 1. For 10, I can give, for minus 10, I can give you identity element as minus 13. Is it correct? Is this correct? Is this correct? This is wrong. This is wrong, because remember, identity element is fixed for all. This identity element, this is fixed. This is fixed for all. For all element, this should be fixed. Okay, so identity element is fixed for all. So whatever element you give me, that should work with all. Okay, so this is the idea. Identity element is fixed for all. So this logic is wrong. Don't apply this logic. This logic is wrong. Identity element is fixed for all. Okay. What about this? On set of integers, this operation we have already defined. Is there any identity element here? A square plus b. Tell me, what is the identity element? What about this one? Is there any identity element? Can I say 0 is the identity element? Will 0 work as identity element? 0 is not the identity element. Remember why? See, 0 has 5. What is that? 0 has 5 is 5, right? 0 has a, that is a. So why 0 is the identity element? It seems 0 is the identity element. It looks like 0 is the identity element. But remember, what is 5 has 0? This is not same as 5. What is a has 0? This is not same as a. So this is not identity element. Answer is no. So here there is no identity element. In this structure, there is no identity element. So do not forget about this one. So many students, they forget about this. 0 has 5 is 5, that is fine. But 5 has 0. This is not equal to 5. So there is no identity element here. We have seen three property: closure property, identity property, associative property. Closure property is same as binary operation. Closure property, binary operation, these two are same thing. Okay. Then we have seen associative property. How to check associative property, and what is identity property? What is identity element? For set difference, we need set of set. Yes. See, if you want to define this operation, set difference, then what should be your base set? Can anyone tell me? If you want to define this operation, set difference, this is your operation, then in your base set, everything must be a set, right? Then in your base set, everything must be a set. Everything must be a set. In your base set, everything must be a set. So this should be set of sets. If you want to define set difference operation, just think about it. If you have this base set 1, 2, 3, this is your base set, then you cannot define set difference. This operation you cannot define set difference. Okay, so this operation you cannot define. Because in your base set, these are the elements. Remember, these are the elements. Actually, let me tell you, this binary operation is actually, let me tell you, this is the final thing. This binary operation is a function actually. This is a binary function actually, let me tell you. Or I can say this is mapping. This binary operation, this is a mapping. This is a mapping. Mapping means function. This is a mapping. Mapping means function. What it means? So if you have this set, like let's assume this set and this operation you have, then hash is binary operation. When can I say hash is binary operation? Hash is binary operation if and only if this hash is a function from where to where. Can anyone tell me? This is a function from where to where? This is a function from S cross S to S. So this is a function. Like for example, let me give you the example. For example, if you take this set, let's assume your base set is true, false. This is your base set, and this is conjunction. Now you can notice that this is a binary operation. Why this is a binary operation? You can notice this is a binary operation, and this is your set S. So this is actually, this conjunction is a binary operation from S cross S to S. Why? Because you can take two elements. You can take true, true. You can true, false. You can take false, true. You can take false, false. And this is your S. So now you can notice that this binary operation is a function. This binary operation is a function. Okay. Is this clear? So binary operation is a function. For example, if you take this one, let's assume that your base set is set of natural number and operation is addition. Now you can clearly see this addition. If you notice, this is a function from n cross n to n. This is a function. This is the domain and this is the codomain, and this will happen like this. So you have, for example, you have 1, 1, you have 1, 2, you have 1, 3, you have 2, 1, and so on. And what will be their image? This is your n, this is your n cross n. So this, if you notice, this addition is a function. This addition is a function. So for example, this 1, 1, this will be 2, this will be 3. Okay. For example, this will be 4, this will be 3. So something like this, and so on. Is it clear to everyone? So these examples you can take. So basically, this S, okay, so this is the idea. Binary operation, this is a function, this is a mapping. This is a mapping from S cross S to S. So this is a mapping, this is a function. If this is a function, then how can you say it is closure property? If it is a function, how can you say it is closure property? From this definition, see, okay, hash is binary operation. Hash is a binary operation. on S. Okay, if and only if this hash, this is a mapping from S cross to S to S. Okay, so this hash is a mapping. Mapping means function. But how can I say that this is, how does it relate to closure property? How does it relate to closure property? Anyone? How will it relate to closure property? Because codomain is a set, is your base set. The answer is codomain is base set. Just notice, codomain is base set. So it's like this. The final result again, so you can notice S comma hash. This final result will be in the base set, right? What this means, whatever two elements. What this means? This means whatever two elements you take. So this simply means that whatever two elements you take any two elements A comma B, the result is in the S. The result is in the set S. So this is the reason I can say this this binary operation, this relates to closure property. Is it clear? Any doubt in this? For example, you can take this set of integers. Okay, let's take set of integers comma hash, this new operation, and this new operation is like this: a hash b is equal to max of a comma b. Now you can clearly see this is actually a function. This hash is actually a function. This hash, this is a function from n cross n to n. In n cross n you have 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, and so on. And here this is your n. Here you have 1, 2, 3, and so on. So okay, and this is your n cross n. Now you can clearly see that 1 comma 1, that will be, so this hash is a function. 1 comma 1 is 1, 1 comma 2 is 2, 1 comma 3 is 3, 2 comma 1 is 2, so something like this. So you can notice closure property is satisfied because whatever two elements you take, the result will be here. Any two elements you take, this simply means that you are taking two elements A comma B. This is in natural number and this is also in natural number. So you are taking two elements and their result, this is mapping to some element in the codomain. So this is mapping to some element which is in the codomain, which is in the base set. So this is how this binary operation relates to closure property. So both are the same thing. Binary operation, closure property, both are the same thing. You can actually say like this: set of natural number comma hash, and this your operation A hash B is equal to max of A comma B. So you can actually say like this. For example, can anyone tell me what is 2 hash 5? 2 hash 5? This will be 5, right? This will be 5. So I can say this will be max of 2 comma 5, and that will be 5. You can also write like this: what is the hash of this 2 comma 5? What is the hash of 2 comma 5? This is also, you can, okay, both are same. These both things are same because this hash is a function. You can notice this is a function because this is a function from n cross n to n. So that is the reason I can say hash of 2 comma 5, that is 5. For example, if I ask you what is hash of 1 comma 100, that will be 100. Just one last example let me take, just for clarity, if anyone has any doubt. This implication, let's take this implication. Now you can notice one thing: is this closed? Is it closed? Can I say this is closed? Yes, this is closed, right? Because why this is closed? Can anyone tell me why this is closed? Because this is a binary operation. Because this is a binary operation on true comma false. Now you can notice that these two things are same. I'm writing parallelly. These two things are same. When you say that true implies true, the result is true. Actually, what it means, it means something like this. These three things are same. Parallelly, I'm writing these three things. So when you say that this true comma true, this is this, then actually you are saying like this, that true comma true maps to true. What you are saying? You are saying that true comma true maps to true. Correct? Okay. So basically this implication is a function, I can say. This implication is a function from this set to this. So, and I can also say this implication is a function. This implication is a function. So what is implication of true comma true? Because this implication is a function, so you can treat as f. You can think as f. This implication you can think as f. So what is f of t comma t? That is basically t. That's the idea. So all these three things are same. For example, if you take these two elements, true comma false, these two elements you take, your elements are these. Then what is this? This is false. What it means? It means that for this element, the mapping is false. Or I can say, what is implication of true comma false? That will be false. If I take these two elements, false comma true, these two elements I take, then the result will be true. What it means? Implication of false comma true, that will be true. So it means if I have this false comma true, then the image will be true. And similarly, if I have these two elements, f comma f, then this will be true. What it means? It means that if I have this f comma f, then the image will be true. For this also the image will be true. So all these three things are same. All these three. So this binary operation is a binary. Binary operation is a function. Basically, you can treat this binary operation as a function. You can treat this implication as a function. So all these three things same. Let's assume you have a set A. Let's assume you have a set A. Then tell me, power set of A, set difference, is it closed? This is a set difference. What is the base set? Can anyone tell me here? What is the base set? The base set, what is this? Base set is PA, not A. Remember, this PA is the base set. This PA is the base set. Okay. Now tell me. So for any set A, you have some set A, PA comma, is this closed? Is this closed? Yes, of course, this is closed. You can take any two subsets. Basically, why this is closed? Can anyone tell me why? This is closed. Why? Because if you remember, what are the elements in the base set? Can anyone tell me? What is the element in the base set? What are the elements in base set? What are these? Or elements in base set? These are subset of A. Element in base set. Elements in base set. These are subset of A. These are subsets of A. Now, if you have two subsets of A, so let's assume x comma y, which are subsets of A, then can I say that x set difference y will be a subset of A? If you take two elements from this base set, remember, here base set is this. This is very important, that your base set is P of A. And in this base set, every element is what? What are the elements? Elements are subsets. Elements are subsets of A. So if you take two subsets of A, you take two elements s comma y, which are subset of A. It simply means that x comma y, they belong to power set of A. So they are in the base set. X comma y belongs to power set of A. Now, if two things you take which are subset of A, then definitely this difference also will be subset of A, right? So this is the idea. So yes, this is closed. And what about other properties? Is it associative? The answer is no. Set difference is not associative. Set difference is clearly not associative. Let's assume your set A is this. Your set A is ABC. Then you know what is power set. Power set is basically subsets of A. In power set, we have subsets of A. So you can take these three elements. Very good. These three elements you can take. Is this same as this? These three elements you can take. So tell me, is this same as this? Are they same? Are they same? Are they same? So you can notice that this whole thing will be 5. This whole thing will be 5. And this whole thing will be this. So I can say, yes, they are not same. So this is not associative. Set difference is not associative. So is this associative? Answer is no. Is there any identity element? Do we have identity element for this? P of A set difference. Do we have identity element? Is there any identity element? There is no identity element. Can I say 5 is the identity element? A equal to 5, will it work? No, because remember, x minus 5, that will be x, that is fine. But 5 minus x, this need not be x. So don't forget about this. So there is no identity element here.